Hello. Can everyone hear me okay? Just wait for a few more people to come in. There are lots of seats down the front, you don't have to crowd up there.
Yeah, easier, but I think I can get the room from anywhere. Middle, then obviously things don't go around. Four in a row.
Yeah, that's Peter still. Right, let's get started. Can all the people who've just come in hear me okay? Say that as a yes. My name is David Cantrell. I am a programmer who work for UK2, who are an ISP. We do some of the same sort of products as Backmark do, although for different audiences. And this is true. I really am the chief plumber. As of a couple of days ago, my boss promoted me to the chief plumber in charge of rescuing princesses and eating mushrooms. This talk was written without any mushrooms. And it's, although, yeah, okay, it's a silly thing off IRC, it is also kind of true. In that we have a team of several programmers. Most of the others work on shiny new features, things like that. I'm concentrating mostly on improving the quality of our code and on performance. So I spend most of it up to my elbows in other people's shit. I represent that. Who's the princess? Right, so, most of what I'm going to talk about is only really useful if you're working with a large code base. I'm talking at least tens of thousands of lines of code. I did a quick count this morning before I came in. The code base that we're working on at UK2 is 130,000 lines of code. The one I was working on before that, when I was at the BBC, 170,000 lines of code. Not much of what I'm going to talk about will be useful if you're merely maintaining a module on the CPAP. So this is what...
Overkill is always good, though. Overkill is always good.
Overkill is always good, yes. I have used some of the stuff I'm going to talk about in a Perl module, which I'm going to show you, which is about that big. So this is what a typical application looks like. So you have lots of entry points in which users can come into your application and interact with it some way. This will basically deal with translating what comes from the rest of the application into whatever your user interface is. In these benighted times, it's usually with the web. It will also deal with doing argument validation. And we'll then pass it through to another layer of your code which massages the arguments a bit, maybe makes a few basic choices based on what the user has said. It then goes into the object layer that's inside your code, and to the database, and you've got some utility things, and then these, your DBX class modules, or whatever you're using for your database layer, will then talk to the database. You've also got a bunch of external stuff that your application talks to, so you've got configuration files, You might be sending and receiving email automatically, talking to third-party web services. Well, I'm not going to talk about those much. Right, so let's run a test of our application to see if one little bit of it works. Okay, so you make an HTTP request to your application. It hits the outer layer, which has a look at what your arguments are, validates that they're okay. It calls some utility code, which is shared between everything, to maybe authenticate that the user who is currently logged in is allowed to do this. Massage the arguments a bit. Try to construct an object that is deep inside your, to do with one of your business object model. Call DBits class, go to the database. You get a bunch of other stuff back, which calls an awful lot of code. And because your application may not be particularly well refactored, even though you called something that's way over there, it's going to call, it might call some of your other business logic, which then of course calls a bunch of the other stuff inside as well. This is all true. We got a test failure. Can anyone tell me where that was?
The fourth one on the yellow bit.
I was going to say in your code base, but sometimes that's not even true.
Well, yes. If we were talking about all the third-party stuff, then it could be because we're talking to a DNS server somewhere which had a brain fart. So what this brings us to, why on earth do we write tests in the first place? Right, that's the least important reason for writing tests. It's actually quite easy to get your code right. I see that many people don't believe me. That is far more important, because when you're getting your code right, it's really easy to break other code. Especially because when we call this all the way up here, you don't actually expect that by the time it's got down to this stuff here, there's going to be a magic call out to here. So if you're hacking on this code, you can make it pass all of the tests for this, but then break the stuff up there. So that is the other reason for testing, and it's important to know what you broke, because, and where it is, because it's useful for debugging. If you don't, if your tests don't tell you where the problem is, then you're going to waste so much time trying to find it. So, right, let's have a look at a somewhat naive solution. So, you start by running the exact test we just looked at. You start by making an HTTP request, it calls all of this code, and it may pass or it may fail. And then you call it starting one layer further down. And one other layer down. And so on. And you keep doing this for a very long time. This will, given if you do this for each of your layers, it will show you where the problems are. But it's a right pain. You've tested most of your code multiple times. These things here, they will have been tested once for each of these things on the outside, for each of these here, probably for several times for these. And this is a very, very big problem. First of all, it's boring as hell. When I say that tests take 2 hours, they really, when I was at the project I was working on at the BBC, the test suite to run the full test really did take 2 hours. And that means that you don't run them all that often when you're working on a new feature. Because, Nick?
I was just going to interject, it's hopefully useful. I think one of the most useful things I did on the Perl core was parallel testing working, so that instead of taking 30 minutes to run the test suite, it got down to about 4.
Yes, it depends on when, in a case of lots of applications, you're I/O bound, or if you're talking to a lot of external services, you're bound by network speed, and so running things in parallel won't necessarily help.
But the philosophy is the same.
Yes. But what this means is you don't run the test all that often while you're developing. You run the tests for the little bit of code that you're working on, so you can be confident that that works great. But after you've been working on something for 3 or 4 days, and you think it's just about ready, then you run all the tests, which you haven't done before because it's boring. And then you find all of the problems you've caused. And you don't know which bit of your code caused which problem. So you have to go through everything very carefully, find where the problems are, and so on. And you have an even bigger problem when it comes to merging your changes from your branch into trunk or master. Because if you're a good, conscientious programmer, when you merge, the first thing you do is, okay, you've run all your tests, you know that your branch works, everything passes. Okay, so you then make sure you've got an up-to-date version of trunk or master. Depending on who you work with, you may not trust trunk or master. So you may have to run all the tests in trunk, which takes 2 hours. Then you do your merge. And to make sure that the merge didn't break anything, based on all the other changes that have gone into trunk, you run all the tests, which takes another 2 hours. So that's 4 hours of testing. Yes, Dave?
Quick question. Would you recommend actually merging trunk into your branch so that you then have the up-to-date version?
Yes, I would. Yes, I think you still have the problem that you do still want to run all the trunk tests before doing that. Because you don't want to merge broken shit into your branch.
Okay, so you run the trunk tests on your branch, and then you merge trunk into your branch, and then you run the trunk test again. Okay.
So anyway, okay, so you've merged, then you run all the tests again to make sure that the merging didn't break anything, and then you can commit. But remember, the tests take 2 hours between you merging and you committing, which means other people might have made changes. So you need to have an exclusive lock on trunk. The team I was working in at the BBC, we did this by handing around an access control token. It was a small stuffed camel. There were 6 of us, 8 of us, I can't remember. And there would quite often be a queue of 3 or 4 people waiting to get permission to merge the trunk. Now, that's basically a day's work wasted twice a week for people who are just not doing anything because they're waiting to commit. So this do not like. And my keyboard just turned itself off. That's better. Oh yeah, and if you did break anything, if running all tests did come up with any problems, well, you're going to fix them, and then you're going to have to run all those tests again, so you can double all that time wasting. Right, that was not unit testing. Unit testing is when you test the smallest possible amount of code. So you test just these little utility functions on their own, without anything else. Or you test just these 2 bit layers together, which are quite closely tied together, without testing all of this stuff further down in the stack. And then you test another 1 or 2 things together. And yes, there's a lot of tests you have to write. You tested all the code once. The tests take 20 minutes instead of 2 hours. Yeah, okay, you still potentially have the problem of having to wait for permission to merge into trunk. But you know what? I don't really care. So, does anyone have any questions about those sort of testing strategies.
Just testing a small part, does that ensure that things work as well in a use case scenario?
I have anticipated this question. I have it about 30 slides later. No, you do still need to have some end-to-end tests, but you don't need to test absolutely everything end-to-end. You don't need to go through all the possible options.
Two modules that are at the end of the call stack using test and isolation, but then you have other modules whose operation uses lower level modules. So how do you run those higher level? How do you test those higher level modules in isolation? They inherently invoke the smaller ones.
Yes. Can we put that on hold for a moment? Does anyone else have any questions? I have lots of slides to answer that one, you see.
Is there any question that's not covered by...
Let me see, what did I have for breakfast today? Nothing, because I got up too late. And my favourite tea blend is a Samoran from nothingbuttea.co.uk. Alright, let's look at some code. It's a very, very simple little web app that I wrote. It takes two arguments and adds them together. And that is all the code. It fits into it. Oh dear, that's really not very nicely rendered, is it?
So you should use black background.
Looks great here. Yeah, that is... can everyone read that?
No.
Oh, okay.
Make the font bigger. No, I think
That's a screen capture.
I think the problem is the yellow and white is the...
Yeah. Okay, so small shell script which starts up the web server. The application itself is written in Dancer, which has its own built-in web server, so there's no hatchet or anything. This is a little bit of Dancer code that basically defines the /add/ whatever it is URL, does a little bit of massaging of the arguments and passes them through to this code here, which will look much clearer on the next slide. There it is. Oh dear.
My usability book.
Unfortunately, there's not much I can do about that.
So the license is probably here.
Oh yes, how do I do that?
Here's how if I lean on it.
Yeah, I think that's kind of yeah.
Ooh, magic.
Darker, lighter?
Yeah, that's right.
Is that readable?
Better.
Okay, so this is the sort of testing we looked at right at the start when you do an end-to-end test. So this is the core of the application, and these are all the tests, sort of. You need that as well because the whole of the application is basically just a wrapper around www Google Calculator because it gave me something to talk about, not because it's a good design. Yes?
What about mocking the Google Calculator or the Google service instead of relying on it being live when you run the test?
If you can mock it, then
Yes.
why use Google at all?
Yes, I'm going to get to that. but this is how you do an end-to-end test. So first, you make sure that Google is working, and if it isn't, you skip all the tests. If Google is working, okay, you then try to you test for failure. Testing for failure is good. You want to make sure your application does actually fail when you want it to. So try to add 2 and 11. And yes, we get back a "you really didn't want to do that" response. And then we
It's the wrong code. It ought to be 400. The problem is with
no, it's
the
an
call, not
internal
the internal error.
Yeah, it doesn't matter. So then we have a test to make sure that this is basically testing that if we ask for the sum of 2 and 4, we really we get back something that says yes, okay, you can do that. and then a test to see if you ask for the sum of 2 and 4, you get back the correct result. So that's just testing that we are asking Google for the right thing, massaging our arguments correctly. Right. Those 3 tests took 8 seconds to run. And yeah, once you've scaled this up to a proper application which has 100,000 tests, 200,000 tests, you don't want them taking that long.
You drink a lot of tea.
Yeah. Okay, yes. Good argument. Okay, right. End talk here then. Okay, so the first thing we can improve is we can get rid of the front layer of the code. We don't, here we are testing that we can get stuff from the dancer layer into this code. We're testing that 1, 2, 3 times. So we can get rid of that. This code hasn't changed. These are the new tests. So we're testing that if we call this method directly, and we ask it to add 1 lemons, we're testing that this little bit of code here works. So does it again? It's a test for a proper failure. And then we have, we pass section arguments to it, make sure we get the right results back. That will have made things a little bit faster. In this tiny application, the change isn't measurable. In a big application, it most certainly will be, because you will have stopped your code from going through Dancer or Catalyst or whatever it is you use 200,000 times. And Dancer and Catalyst, they're big, they do a lot. They have to make a lot of decisions. Even if what you're doing is simple, it will still take a lot of time to do that. But we can make these tests a lot faster, and we can make them better. So we're going to start mocking the call to Google. So first thing we do is use class mockable, which we'll use that to insert a shim in between our code and www Google Calculator. What class mockable does is it inserts this method, which I call _Google_calculator. It inserts that into your class, and it will by default return this. So just in the class. It will also insert another method called reset Google Calculator, which will reset this to that, and this is both a getter and a setter. So you can call it with no arguments, and it will just return whatever you expect. If you call it with an argument, it will set what it will return the next time. And there's not really any other changes in here, apart from instead of accessing Google Calculator directly, we access it via this method here. So what we're going to do later is we're going to use the fact that this is both a getter and a setter to insert something else into the code so that we can mock it. And these tests here are exactly the same as what we had last time. So this code still works. This class here, Dancer, example, calculator, utils, Google interface, it has a horribly long name. Here it is, that is the entire class. It just has one class method, which instantiates a Google calculator, passes arguments to it, and strips a bit of noise off them. So those are the tests we had a minute ago. Now we're going to start using mocking to get rid of all the extra layers of code so that we can look at just that one layer in the middle of our application that we're interested in. I like to do this. So these are the normal tests. We're adding that we're checking that we can add 0.2 and 1 and get back 1.2. Just to prove that we really are mocking, I've changed the test to see that we add 0.2 and 1, get back 11. Just to prove that we're not actually going out to Google every time. And then we put this in the test as well, So this is calling that method that we defined using class mockable. And it passes, so it's setting what the Google calculator method will return. It sets it to be a class mock generic interface tester object, and it passes all of this data to it. Now what this is, what that means is each time that the Google calculator is called, it will return this object, and this object then expects to be called with its expects to have its calc method called with these arguments, and it will return this. And then it expects to be called with, again, the calc method with these arguments and return this, and so on. And what this will do is it will check that our code is calling the mock correctly in the way that we expect. So we expect our code will call calc method 4 times with these inputs, and we're actually going to check that we're doing that. If we call the wrong method, that will spit out a test failure. If we call a method with wrong arguments, so if we're not massaging our arguments correctly, that's a test failure. If we try to call a method more times than we've defined, that's a test failure. And if we don't call it enough, that is also a test failure. So if we don't use all of these fixtures, we will get a test failure.
Is there any way to...
That means that if you extend your test suite, you need to coordinate the extensions in 2 places if you don't want to.
Absolutely, yes. Yes, for your tests you need to define fixtures.
Is there
and these are the fixtures for testing the interface between your code and the next layer down.
So is there an easy way to test that your mock object accurately represents the way in which the object that it's mocking behaves? Because if you bugger up your mock object, you then coding against something which isn't.
Yes. You could use a mock. You could write another mock which basically passes all of its arguments straight through and records what we did, and then you could use that recording to set up these fixtures in the first place. But what we're testing here is we're testing the interface between the code that's under test and the next layer down in the application. If we go back quite a long way, so in this case, we're hitting this bit of the application. We're okay for it to also run this at the same time, but we don't want to call this. So what we're testing is the interface to make sure that this calls this correctly. But when you're testing, what you're interested in is the output correct? And the output is not just what you return. The output is what you do to everything else as well. So what this does to this is an output. And that's what this mock interface tester is testing. It's making sure that the call is correct.
Is the yellow part the bit you're mocking?
Sorry, what was that?
Aren't you mocking the interface of the yellow bit?
You are mocking the interface between here and here.
So what's the orange bit?
Oh, sorry. Sometimes it doesn't really make much sense to test each little unit on its own. I mean, if we look at, if we go right back to the beginning, and you look at the, actually let me go to, unfortunately you can't see it very well. This code here, for instance, isn't really worth doing unit testing on, because it is just so simple. So sometimes you will call something which you don't need to bother unit testing, and it will just call through to something which is a little bit more complicated and does need unit testing. And so that's why you want so this is where you want to do your mocking here.
Also, I think it's quite an important point is that the top left code there is basically just, it's a one line of code. It's invoking lots of dancer behavior, and so you don't want to be basically re-implementing dancers tests.
Yes, we can trust that the dancer tests are okay. Dave, we can trust that the dancer tests are okay.
Yeah.
Good. There you are. Straight from the horse's mouth.
Just on that point about does the mock object reflect the true behaviour of the underlying object? I mean, you've actually deliberately made sure that it doesn't, because you put some duff sums in there that did not add up.
That's really just to prove that we are actually mocking.
But the implication of that means that you couldn't just take that set of tests and then expect them to work if you then did let it go through to Google, because suddenly Google would start giving you the right answers, and those are not the answers you're now expecting.
Yeah, this is you would want this. I think that's where you would want to do end-to-end tests.
Right.
So where you would test your whole stack in one go.
So I guess what I'm getting at though is you're not having dual purpose code where you can say either go all the way through or use the mock object. You've got code that's now only test code that's only going to work with the mock.
Yes, because the code that goes all the way through is these tests. You probably only need two of those for the root, whereas to test this properly, you need 8 or 9 tests, because there's 8 or 9 different failure modes. It will fail if you ask it to add 11. It will fail if you ask it to add 0.2. You can either decide that 0.2 is the proper number. It should be 0.2 or things like that.
I think the key here is that you're not testing Google. Google can test itself. You're testing the code that you've written. If Google gives you the right answers.
Yes. What we're testing here is the code that takes input to this method and massages it, turns it into the string that Google wants, and then passes it to Google. We're not interested in testing Google. We're only interested in testing this method. So we're testing that we get back the expected result, and we're testing this output as well. So this output is the call to something else.
If you could go back one slide, I think. A couple. Go back to the Vim split screen. Yeah. Yep. So in the bottom one, on line 15, there's a regular expression.
Yep.
That you're no longer testing with your mocks output.
That is because it is now here.
Okay. That's in the. So you're not testing that.
I bundle it up in the Google interface.
Got it.
And those tests, all 8 of them, the same tests as we showed earlier, which took 3 seconds. No, sorry, we looked at 3 tests earlier, which took 8 seconds. These tests do quite a bit more. There were 8 of them, there's more than twice as many of them, and I couldn't time how long it took.
They didn't catch your regular expression bugs. They didn't catch your regular expression bugs though.
I don't believe there are.
If you pass in Devanagari digits, then it'll pass them through to Google.
Oh yes,
probably not treat them as decimal.
I'm not interested in silly things like that. So, does anyone have any questions? I'm sure that someone is going to ask that one. Oh, in fact, they already have. Yes, you do need to have some end-to-end tests for your entire application. You cannot rely on mocking to do absolutely everything. You still need to make sure that this will test. Doing unit testing will test that the interfaces between the bits of your code are what you expect them to be.
So
this will test that they are correct. So yes, you still need some end-to-end tests. Mocking everything seems like an awful lot of work. Yes, it can be a lot of work. So be pragmatic about it. You don't have to mock absolutely everything, obviously. What I would suggest you do is you make all of your dependencies that are outside your application mockable. So, the code that reads your configuration file, for example, that should probably be mockable. Anything that talks to a third-party web service, that should be mockable. Calls to... yes, sorry?
I have a comment on that. You don't need your extra module to make things specially mockable. Everything's mockable by virtue of monkey patching.
Monkey patching is bad.
I do it all over the place in our unit tests.
I do it as well, but it's lazy. And it is not, it's nowhere near as maintainable as it should be, and it can have dodgy side effects. If you use mocking like this, the fact that I made the Google Complicated method is get a resetter, so you can set it to mock, but then there's also a reset method, so you can specifically unmock.
This is what local is called. You can do local stuff to equal sub.
Yeah, you're starting to get into strange magic. That could have unexpected side effects.
Would you be able to differentiate between development tests in which you mock versus deployment tests in which you switch the mocking off towards the actual testing?
Yes, I mean, developers certainly need unit tests. It's probably a good idea for the developers to have at least some end-to-end tests as well, just to make sure that, as I said, when you mock, you're testing that your interfaces are what you expect them to be, whereas when you run the end-to-end test, you're testing that they're correct, so your expectation is correct. Yes, your QA people or whoever it is who pounds on the web interface to make sure that it does what the managers expect. Yeah, they would like to have a set of end-to-end tests. Those would quite often be using something like Selenium as well. Okay. I would say certainly make everything outside your application mockable straight away. Mocking all of the individual layers within your application takes a lot more time, so you need to be more pragmatic about it. People keep asking about and no. Yes?
How would you convince a developer who doesn't like testing, because that does exist, that testing is good?
I'm sorry, a developer who doesn't like testing?
I know some of them.
Yes, unfortunately, it's sometimes a bit too difficult to find people. Make them fix their bugs.
Show them the video of the missile launch that spun off into the sea because someone had typed a full stop instead of a comma in a Fortran program.
So I have sort of a question. So basically the whole approach is a model where you specifically create objects that are not fully featured, as it were. You're asserting that you get exact method calls at exact times. And then you end up with very fragile tests where you suddenly say, I expect you to call this method and that method, and then like the order changes or something.
Yeah.
In a not very important way.
I think that's a feature of a bug. Something in your code has changed, and therefore the test should change as well. And if you can change the code without changing the tests, then your tests probably aren't actually testing what you think they are.
But a lot of the times, especially when it's just things like ordering like that, it tends to come out as things that didn't actually make a difference.
Yeah,
sometimes that is true, but a lot of the time it isn't.
Yeah, you do need to think about what you're going to test. If you can change the code without changing the test, then it indicates that, well, it could indicate that you're testing whether your code achieves the right result, and you were successful in your changing, it didn't change the result. Or you might want to add a new test to check that whatever you were changing has actually changed.
Yeah, because if the order in which you're making calls to a third-party web service has changed, then the output from your code has changed.
Yeah.
If it doesn't matter, then okay, then maybe you just shouldn't mock that in the first place. But if it does matter, or it could matter in the future, you know, if they change the internals of their application, then I think it probably does need to be tested.
I notice you haven't said test-driven at any point.
You're right, I haven't.
Mostly,
that's mostly because it's much harder to demo it.
Right. I guess my question was going to be, but would you advocate planning for mocking as you write the code?
Yes. If you're starting from scratch, then you should think about mocking right from the start. And actually, if you think about it, then you don't need to do as much of it, because your application design will tend to be a bit better. I'm approaching this from the assumption that if you're working on 100,000 line code base, then it's probably existed for quite some time already, and it is probably chock full of horror.
I'm probably going to look at this thing about monkey patching. I'm not sure how it works under the hood, but is test mock module bad then? Because that doesn't do anything with production.
Test mock module?
Yeah, it does mocking, but you don't have to do anything in the code that you test.
Yeah, you're not thinking of test mock objects, are you?
No, they're slightly different. Mock object gives you an instance of an object, and you can mock methods on that object, and that's specific against them.
Yeah.
Module, you give it a class name, and you mock methods or functions, subroutines on that class, and you can include sort of new in that, so that internal sort of action at a distance, when methods get called on it, they may be mocked or may not be mocked.
That actually brings me to...
Which basically is monkey patching.
Yes, that brings me to something that I'm going to talk about in a moment. You can mock new using this. That's James Roman's fault.
Not fault, it's a feature.
It
didn't work when you gave it to me, it does now.
Yes, but it's nasty code and he wrote it.
Yeah, guilty.
Hold it. Write down the name, thanks.
So yeah, just a couple of things you can find useful. The class mockable, which is now on the CPAN, is in its third release in the last week because I fucked up the first couple of times.
Did the test pick that up?
No, it has tests. It even uses itself in the tests.
Isn't that an end-to-end test rather than a unit test?
So yes, there are end-to-end tests. There are also unit tests for it. So I'm kind of breaking my rule that says that you probably shouldn't, that it's not necessarily worth doing all this unless you're working with tens of thousands of lines of code, because it is only about 60 lines of code. This book is excellent. I recommend it. Can any of you read that little bit of grey?
No. Does it say C#?
Yeah.
It says, with examples in .NET. Now, those of you who were here a little while ago for Pierce's talk, he was going on about how we could steal great ideas from other languages. So yeah, steal this stuff from .NET. Because that way, .NET is actually useful for something.
Presumably, though, part of the reason for providing a special feature that you use instead of the real class name is because you couldn't monkey patch it in C#.
Probably true, yes. But I still think it's cleaner than monkey patching.
You were to broke it.
On the subject of test-driven development, do you think it's feasible to drive development by tests that involve mock objects?
Yep.
It looks rather cumbersome for that.
Yeah. When I was first introduced to real test-driven development, which actually I'm not sure that people who are talking about test-driven development are the same thing as I am. When I was introduced to real test-driven development, I thought, Jesus Christ, that looks like so much work. I don't see the benefits. And then I did. Someone showed it to me and how it was actually useful, and Yeah, it makes your code look completely different from how it would if you were to just write a few tests and then write some code, and then write a few more tests and write some code. Real testing requirement is you write one test and you make it pass. Then you add a test and you make it pass, and so on. I was thinking of talking about test-driven development next year. I might do, I might not. It's kind of hard to come up with examples. I'm now going to show you what is deep inside the interface tester. If I can find it on this machine. Hooray!
That's better.
Right, that is all of the code for class mockable. Yep. So it has.
It's not replacing anything existing. This is just installing new subdivisions.
Yes. Yes. All this does is it basically takes a hash of arguments. So the keys are the names of the accessors that you want to use for your mock objects. The values are the mock objects themselves. It maintains its own list of what those are with singletons. It creates the method and it creates a reset method. Alright, so this is the getter and setter form. So if you pass in an argument, it sets it to be, it sets the singleton to that argument and then returns it. If you don't pass in an argument, it just returns the singleton. And when you call the reset, it sets the singleton back to whatever it should have been in the first place.
Why is it using a single global hash of all the mock objects rather than, say, a lexical variable scoped within the loop?
Because it was easier.
It would be easier to have a single variable per mock object.
Well, it made sense at the time anyway. Okay, so let's go back up to the top of this. Okay, so this is the interface tester. It uses autoload, which is evil. It overrides test more okay. Well, it mocks it anyway. It has lots of documentation, possibly too much. There is such a thing as too much documentation. Axiom has too much documentation. None of it is useful. The Axiom documentation is, it has all of the features and all of the options, and there is no index to tell you what the hell they are and what you're looking for. Right, so when you construct the new block object, as we saw, you pass in a list of what the tests are that go in here, and there's a bunch of other stuff. And then whenever you call any other method on it, we go to autoload. And the first thing it does is it looks to see if there are any tests left. If we've run out of fixtures and we try to call one of them, that's a test failure. Okay, so assuming that didn't happen, right, we now have the next fixture. Test that we're calling the correct method. So, this is testing that you're calling things in the right order. If you didn't call the correct method, that's a test failure. We can ignore that stuff about code references. So it then compares the arguments that you passed into the method to what was expected, and if they're not exactly the same, that's a test failure. And finally, if the mock object goes out of scope and you haven't used all the fixtures, the destroy method picks that up says, oh, there's something left. That's a test failure. So, yeah, it's testing that you are actually using all of your fixtures, as well as testing that you're using them correctly. And the bit I'm going to blame James for, you might want to, the code that you're mocking will probably have calls to new in it. The problem is, this has a new method, so that won't happen. So, if new is called on a class instead of on a package, then we set autoload to what it should be, and then we call autoload. Magic.
You are welcome. That's my turn, sorry.
And then James also did the bit for which deals with code references. I didn't bother showing you as well. Right, we have 1 minute left if anyone has any more questions.
You
take picture requests.
Yes?
Record later.
Yes, there is. Can you put it on GitHub issues, please? Thank you. With a patch, would be better. Anyone else?
What's a good English cider?
Tricky. There are quite a lot of them. If you want something you can get everywhere, I recommend Old Rosie. And I recommend getting it from Chimes in Pimlico, where they sell it by the 2-pint jug.
You'll learn to eat one.
It's a pub that doesn't sell beer. It just sells cider and root wines and lovely spirits. I think it's a very good food as well. But, thank you.